Hey class, good evening everyone. How are you all doing today? I hope all of you are doing awesome. And today we are going to start a new chapter, and as decided in the poll, we have released a poll last night and we have got many votes. So based on that, I have picked two topics. One is cyclic quadrilaterals and the theorems related to the chords. So one topic I have kept this theorem related to chords because there are many theorems which are related to this part, so that the most of the part will be covered. I don't want you to lose any of the points anywhere. That is why I have distributed the points in such a way. Now there was a topic 3 points on a circle, so that was a quite easy topic, right? So based on this, all the theorems we'll be doing. So the first and most important thing I would like to tell you all is remember the theorems, because unless you'll remember the theorem, you will not be able to apply them. Okay, you should have this thing at the back of your mind. Suppose for the topic quadrilateral I'm saying, you should have this thing at the back of your mind that okay, in a parallelogram opposite angles are equal, right? Adjacent angles are supplementary. Okay, so these things should be kept in your mind. Then only you'll be able to see what path you want to reach to your answer. Okay, so that is how you will make the planning if you have all the resources available. So here the resources in your geometry is all the theorems. Okay, all the theorems, all the theorems, all the things which we already know, those becomes your resources and they help you to get to the answer at the final stage. Understood? So this is very important for you, all of you, to remember all the theorems in the chapter circle, especially this chapter circle. Most of the students will call it theorem chapter because so many theorems are there inside it, but the theorems are quite easy. Okay, moreover they are just nothing but like taken from the if you have understood the topic triangles properly, so all the theorems are based on that only. You are just using the congruency of triangles and you are proving the things, right? So don't worry much about this topic and let's jump ahead with today's class. But before that, let me tell you one thing. Do like, share and subscribe to this Vedantu's grade 9th and 10th channel, because as I have told you, it's the only channel which is working for 9th and 10th class domain. Also, the second most important thing you will be getting is many of the students, your cousins or your brothers or your far distant relatives, those whom you think that they are in a small town and you want to help them out to have the same level of teaching where you can get it any point in the whole India, right? Be it you're from village, be it you're from Mumbai, Delhi, from a bigger city or from a small town. No partiality should be there, because the extent of education should reach to everywhere. Everyone has a right to education, but we at Vedantu says everyone has a right to quality education. Okay, so to make us reach to this goal, do subscribe to this channel, do share this channel to your other friends or schoolmates, those who are not aware about it, so that each and everyone can get the benefit of this huge platform. Okay, so let's move ahead with today's part. So this first we'll discuss the homework question which I have given in the previous topic. Okay, and it was quite easy, right? So you can see that ABCD is a triangle and BPC is a triangle with P falling on AD. If the area of parallelogram ABCD is 26 centimeters squared, then the area of triangle BPC. Okay, so ABCD is a parallelogram and BPC is a triangle. So the diagram looks like ABCD. The diagram looks like ABCD is here. Okay, and BPC is a triangle with P falling on AD. Chalo, very good, no problem. So now they are seeing area of a parallelogram ABCD. So sorry, a parallelogram ABCD, its area is 26. So between two same parallel lines, the area of triangle and the same base area of triangle is half of the area of parallelogram. So if area of parallelogram is 26 centimeter, area of triangle BPC will be 26 by 2, which is 13 centimeters square. So you can see, easy topic. It was quite an easy topic. Okay, but I would like to request all of you bacho once again, because nowadays I have started getting less number of answers, and since many of you are already watching the videos, just post the answer. Just be happy that your name will be shown in the next part. It will motivate you for working harder, and your name also you can see anytime on the YouTube and your name will be visible there. So also I would encourage all of you to give more and more answers. Okay, let's move ahead with today's star students, and we have got it from Vijay Raghavan, Neena, Field Physics, Shiven Jangale, Vedashri, Preeti, Umesh, Anushka, Rajani, Heram Damble, Rajani, and two Rajnis are there, na? No. Rajni Kulkarni, two are there, and Nanu Rathod. Okay, and also I'm really humbled and really excited with the comments which I have seen on the last video. So thank you so much, bachcho, for appreciating my efforts, and I really I love you all for supporting me and for loving mathematics. Okay, so let us start with today's chapter, which is your circle. Okay, so in circle related to chords there are some theorem. Okay, so the starting theorems in your this chapter circle, they are all related to chords. So first is, suppose that if you draw a circle, okay, and you draw a chord. So if you draw a perpendicular from center on this chord, this perpendicular will bisect it chord into two parts. So you can say the line joining center of the circle, line joining center of this first is from the center of the circle, if you draw a perpendicular on the chord, so perpendicular from center of the circle to any chord bisects the chord. Correct? Second theorem is just the converse of it. In this we will say that if I join the center of the circle with midpoint of the chord, then this angle will be 90 degrees. So I am saying the like converse of it. So these two are converse of each other, right? Then the next topic was that equal chords, let us say these two chords are equal, so they subtend equal angle at the center. That means if these two chords are equal in length, the angle subtended by them at the center will be equal. The other is just converse of it. If two chords subtend equal angle, if two chords subtend equal angle at the center, then the chords will also be equal. So they are just, as you can see, they are just opposite of each other. So this way there are many theorems. Okay, so you just have to go through it, and the proofs are quite easy. Congruency of triangle has been used many of the times. Okay, so the proofs and all are quite basic. I am pretty sure all of you would be able to easily understand the proof. And also I would like to tell you one more thing, that these proofs are very important. So my advice to all of you is go through all these proofs. Okay, and because in the exams many of times in the circle chapter, major important thing is the proofs of this theorems related to chords, or the question will be asked from the angle subtended by any chord at the center is double of the angle subtended by it at the circumference, or angle subtended by any arc at the center is double of the angle at subtended by it in the circumference. So these kind of questions have been asked lately. Okay, so that is the pattern. And then cyclic quadrilateral, and cyclic quadrilateral I will be taking in your next session. Okay, so that's a very good topic. And in cyclic quadrilateral I will be including some questions of this angle subtended at the center should be double of the angle subtended at the circumference by any arc. Okay, so those two topics also I'll do, and cyclic quadrilaterals proof is also important, so that also I will be taking care of. Okay, so don't worry, your whole chapter I will be covering. And let's start with today's rapid fire round. So the first question we have is this. Write true and false. Chalo, let's write true and false. First thing is justify the answer in each case. First is, two chords AB and CD of a circle are each at distance of 4 cm from the center. So then AB is equal to CD. See, two chords which are equidistant from the center. This is a theorem. If two chords are equidistant from the center, both the chords will be equal. Okay, what do I mean? That if you draw two chords, let us say one chord is this, one chord is this. This is the center. Let us say distance of a point. Always remember, bacha, distance of a point from a line. See, you can join this point and line in many ways, but the distance will be the perpendicular line joining both. So from the point, if you draw perpendicular on the line, that will be the distance between the point and the line, not the other ones. Okay, so this will be your distance. So similarly, this is the distance, and let's say this is the distance perpendicular. They are saying these two are 4, let's say AB and CD. Okay, this is what is given, AB and CD, and they are saying these two are equal. So you have to prove that you have to say that the chords will be equal. So yes, it's directly a theorem that the chords which are equidistant, from the center, they are equal in length. Okay, and converse of it will be if two chords are equal, they are equidistant from the center. Okay, so these theorems you have to remember very well because it's very easy part. Okay, so the proof also you can do it very easily, bacho. It is just the congruency used here, nothing else. Okay, so let's move to the next part. Two chords AB and AC of a circle with center O are on the opposite sides of OH. So two chords AB and AC, opposite sides with circle of center O are on the opposite sides of O. Opposite sides of O, not OA, opposite sides of O. That means if you have a circle like this, okay, so you have two OA, then it is OA only. I thought ABCD it was. So O, center O is here, A is here, B and C. Okay, so opposite sides, OB is on this side, AB on this side, AC on this side. So this is what the diagram looks like. Now they are saying two chords AB and AC of a circle with center O are on the opposite sides of OA. Then angle OAB and angle OAC, these two angles will be equal. Now see, these two angles will be equal, we need to prove it. But always remember, bachon, these two angles, many of you will be having the feeling that these two will be equal, but not in this case. If the two chords are equal, then these two will be equal. Why? See, first main thing is, suppose if I draw the chord something like this, I can clearly show you by diagram also. Suppose this is your AB and if it is your AC, let us say. Okay, so you can see clearly, or if I make this AC more shorter, let's say like this, so you can see clearly the angles are not equal. Okay, so this property is equal only for the equal chords. Here nowhere is written that two chords, it is just saying two chords, not two equal chords. So if it was equal chords, if the chords were equal, let us say if the chords are equal, okay, O, A, B, C and you have O. Okay, so if the chords are equal, you know, when the chords are equal, angle subtended by them at the center is also equal, correct? And then this is an isosceles triangle because both are equal to radius. So these angle will be equal to each other, these angle will be equal to each other. So these two are also equal. So for this to be true, the chords has to be equal, but in the statement nowhere it is given that the chords are equal. So I will say this statement is false, this statement is true. Next, two congruent circles, congruent means equal, okay, with centers O and O dash intersect at 2 points A and B, then angle AOB is equal to angle AOB dash. So let's say we have two congruent circles, that means of the same size, and they are intersecting at 2 points which is A and B. Let's say the center is O, the center is O dash. So they are saying angle AOB and AO dash. Now see, we know one thing, bachon, since both the circles are congruent, so radius is same, so this is R, this is R, this is R, this is R, correct? What do you want to prove? Angle AOB. So you know that AB is the common side, so both the triangles are congruent, so I can say by this thing both the angles are also equal, right? So yes sir, this will be true. So the main thing for this to be true is both the circles are congruent, they are equal to each other, their radius is equal. If the circles are of different size, then it will not be correct. So it is very important to see that which was the key term here. Similar, suppose in second one, if the chords were equal, then it would have been correct. Here, if the circles were not given congruent, then this would have been false. Now, through three collinear points, a circle can be drawn? Obviously not. Arey yaar, you know that any triangle, if it is any triangle is there, you can draw a circle through all the 3 points. But when the 3 points are collinear, maximum you can draw a circle which can pass only through 2 points. You cannot draw a circle which will pass through all 3, correct? So this will be false. Through 3 non-collinear points a circle can be drawn. That is the correct theorem, correct? So the next part is a circle of radius 3 centimeter can be drawn through 2 points A and B such that AB is equal to 7 centimeter. So you have a circle of radius 3 centimeter. Okay, and 2 points you have A and B, and from A and B you have to draw a circle. Okay, so from A, any radius will be of 3 centimeter, correct? So the largest way A and B can be separated is from both A and B will form a diameter, correct? Because the diameter is the largest chord. So for this circle, the largest chord possible is 3 plus 3, which is 6 centimeter. But they are saying ABC are 7 centimeter apart. Nope, not possible. So here, if AB was 6 centimeter, it would have been true, but this would be considered false. Okay, so these are your this is the solution for the first question. Okay, chalo, let's move to the next question. The next question we have is this. If a line segment joining midpoints of two chords of a circle passes through the center of the circle, prove that the two chords are parallel. Prove that the two chords are parallel. So a line segment joining midpoints of two chords of a circle passes through center. So how does the diagram look like? See, you have a circle. Let's say here is one chord, here is one chord, and the midpoint of these two chords, wherever it is joining, it is passing through the center of the circle. Correct? You know one thing, let's say it is E and F. You know one thing, the line joining center of the circle to the midpoint of a chord, this line will be perpendicular to the chord. This theorem we have done, right? So I can say, sir, it means OE will be perpendicular to AB and OF will be perpendicular to CD. Correct? Theorem I have used. If it is true, now you can see, if I look at AB and CD, you can see that AB is parallel to CD, correct? And EF is transversal. Okay, EF is, AB is parallel to CD, we have to prove, sorry. So you know that AB and CD are two lines where EF is transversal. तो भैया if EF is transversal, हैं बताओ मेरे को अब, if EF is transversal, सही में सोचना एकदम, EF is transversal, you can clearly see interior consecutive angles, pair of interior consecutive angles formed are supplementary, see 90 plus 90. So you can see that, sir, angle AEF plus angle CFE is equal to 90 plus 90, which means 180 degree. So this is the converse theorem of interior consecutive angles. If pair of interior consecutive angles formed are supplementary to each other, then we can say that the lines will be parallel. Correct? So this is how you can see clearly that the converse theorem has been used here. Okay. So now let's move to the next question. So the next question we have is this. बच्चों, just now remember the theorems यार. Theorems याद रखोगे ना, everything is very easy. It's very important. And याद रखना means I'm not telling you to mugging up. Okay, develop an analogy, draw the diagrams, you'll figure it out, you'll see the theorems clearly yaar. When you will try to draw the diagram, you'll see ki it is possible, it makes sense. Okay, go for the proofs, again that will also make sense for you. So this way you have to develop an ideology. Okay, so now let's move to the next question. If two circles intersect at 2 points, prove that their centers lie on the perpendicular bisector of the common chord. Chalo, it's a very good, very important question, keeping your exams in point of view. Okay, it's a very important question. If I suppose have two choice to give you question from the topic circle, I would choose two questions. One is from the cyclic quadrilateral, or I would choose three questions. One is from the cyclic quadrilateral, one from this angle subtended at the center is half of the angle subtended at the circumference, and one is this question. So it's a very important question. Now see what is happening here. That two circles intersect at 2 points. Correct? Okay, sir. So when two circles intersect at 2 points, that means the circles are intersecting something like this. Correct? They are not saying circles are of the equal right. Okay, let's say this point is O, this point is O dash, and here you can see this is the common chord. How do you draw the common chord of any of two intersecting circle? Join the point of intersection. So let's say it is your A and B is the common chord. Now you have to prove that the line joining the center of these two intersecting circle is perpendicular to AB, and this is bisecting AB as well. Let's say this is at point C. So for two things you have to prove. You have to prove that OC is perpendicular to AB. By OC is perpendicular to AB, any of these angle is perpendicular to AB. OO dash I would write. Okay, OO dash is perpendicular to AB. And second thing you have to prove is AC is equal to BC. If these things you can prove, then you can say OO dash is perpendicular bisector of the common chord. Correct? How do you go for this part? Again, a very easy topic, bachon. See, what you'll do first, whatever, try to join these. Why? When we can join, you know, joining was required here. The diagram, you were feeling that the diagram was like incomplete, na? So this, let us say, is capital R, small r, small r. Diagram, let me make a larger diagram so that it will be very clear for you, all of you. Chalo, no problem. But these two are radius, correct? And these two are the radius of the other. So both are different, correct? And let's say this is a point C. Okay, now understand what can be done. First, let us talk about triangle. In triangle OAO dash and OBO dash. Which two triangles I'm talking about? These larger ones. OAO dash, OBO dash. First thing you know, O dash A is equal to O dash B, capital R. Correct? Second thing you know, OA is equal to OB is equal to small r. And then the last thing you know, O dash O is equal to O dash O because it is common. So now I have proved that triangle OAO dash is congruent to triangle OBO dash. If these two are congruent, I can clearly say that this angle must be equal to this angle, right? I have got what I needed. This was my purpose. Now let's move to the next part. In next step, I will take other two triangles. Now which two triangles I will take? I will take in triangle AO dash C, AO dash C, and triangle BO dash C. Now see, you must be thinking why I have proved this part. See, when I want to prove AB is equal to AC, I know that in a way I have to prove this triangle congruent to this triangle or this triangle congruent to this triangle. So let us say I choose this two. What are the things I have? I have one thing that these two, O dash A and O dash B are equal. Correct? You cannot say AC is equal to BC. That is what you have to prove. You don't know whether these two angles are equal or not. Correct? So, but you know that this thing that O dash C will be common. So you only have two things. You needed one more thing extra. So that extra thing you have got from that part. Once you have got those two triangles are congruent, I have told these two angles are equal by CPCT. Now I have all the three things. See, now I have all the three things. Now I have all the three things. See what I have. O dash A is equal to O dash B is equal to R. Okay, angle A O dash C is equal to angle B O dash C because of the proof of that part, and then I can say OC is equal to OC. Okay, O dash A O dash B, A O dash C, B O dash C, and OC is equal to AC. So now I can say triangle A O dash C is congruent to triangle B O dash C, and if they are congruent, first thing that I have proved by CPCT, AC is equal to BC. And by CPCT I now know these two angles are also equal, and the sum of these two angles should be equal to 180 degree. So x plus x is 180, that means x is equal to 90 degree. So you got to know this angle will be 90 degree as well. So this is how easily this question can be proved. Okay, so 2 steps proof is this. It's a very important question. Chalo, let's move to the next question we have. The next question we have is 2 equal chords of a circle intersect. If 2 equal chords of a circle intersect, prove that parts of one chord are separately equal to the parts of the other chord. Again, a very good question. Okay, a very good question. What the question is telling you, that you have 2 equal chords. Equal chords, understand the meaning, equal chords. Okay, so let's say you have a circle and this circle has 2 equal chords which are intersecting. A, B, C, D. Center is O and let's say the intersection point is P. You have to prove that the parts of one chord are separately equal to parts of the other chord. That means it is given AB is equal to CD. You have to prove that AP is equal to CP and BP is equal to PD. That means these parts individually are also equal to each other. This is what you have to prove now. Okay, you have to prove that this AP is equal to PC, DP is equal to PP. This is what you need to prove now. How do we prove it? First thing, so you might also be feeling like me that sir, the diagram is incomplete somewhere. Okay, so first thing I know that bachcho, if 2 chords are equal, so now if I draw the perpendicular from center, if I draw a perpendicular from center, you know this perpendicular, let us say OM, ON. These 2 perpendiculars will bisect the chord. Correct? This is the theorem. A perpendicular from center bisects the chord. Correct? So you know if OM, I have done the construction OM perpendicular to AB and ON perpendicular to CD. So if OM is perpendicular to AB, I can say AM. So M is midpoint. So I can say M is midpoint of AB and N is midpoint of CD. Correct? Once this part is done, now you know bachcho, they have given AB is equal to CD. Let us divide this by 2 on both the sides. So AB by 2, which is equal to CD by 2. Half of AB, if M is midpoint, I can say AB by 2 will be equal to AM and CD by 2 will be equal to CN. AM is equal to CN, I have got. Correct? Now let's move ahead. Let's do one thing. Let us join. Wait. Let us join this O to P. Okay, let's join this O to P. You know this angle will also be 90 degree, this angle will also be 90 degree. One more theorem we know that sir, 2 equal chords are equidistant from the center. 2 equal chords are equidistant from the center. That means the perpendicular, if the chords are equal, so the perpendicular which you are drawing from the center on the chord and both the chords are equal, so the length of the perpendicular will also be equal because equal chords are equidistant from the center. So that means I have that OM is equal to ON as well. Okay, so here I will write this part, and so OM is equal to ON. What is the theorem I have used? Equal chords are equidistant from center. Okay, so now let us talk about these 2 triangles. Which 2 triangles? In triangle OMP and triangle ONP. First thing you have bachcho, OM is equal to ON. Correct? Second thing you have is angle M is equal to angle N. Both are 90 degree. Third thing you have is OP is equal to OP. Common. So you can see right angle hypotenuse side rule. So by RHS, you can say triangle OMP is congruent to triangle ONP. If these 2 are congruent, I can say by CPCT, MP is equal to PN. This is my second equation. This is my first equation. Okay, add these two. So you have AM is equal to CN and here you have MP is equal to PN. Now add these बच्चों, AM plus MP will be equal to AP is equal to CN plus NP will be equal to CP. Correct? AP is equal to CP, I approve. How to get BP is equal to CP? Now BP is equal to PD, simple. By if you have AP is equal to CP, you have one more equation, AB is equal to CD. From AB is equal to CD, subtract this equation. So AB minus AP will give you PB and CD minus CP will give you DP. So BP is equal to DP as well. Understood? So this way this question can be proved. So 2 times we have done. Okay, a simple congruency proof you have to solve there, nothing else. Chalo, let's move to the next question. Next question we have, prove that the angles subtended by the chords of a circle at the center are equal, then the chords are also equal. Again, a very easy proof, won't take much time. Okay, what do you have? Here you have that, let's say you have 2 chords and these 2 chords are subtending, let's say, an equal angle at the center. This angle is equal. So I have to prove the chords are also equal. You know, this is radius, this is also radius, this is also radius, this is also radius. So both the triangles are congruent using side angle side. So by CPCT, this is equal to this, as simple as that. What else, yaar? Correct? So you can see the question is quite easy. So I have told you, bachcho, the theorems proof are very easy. Okay, very easy. Don't worry about it. Very easy. Chalo, let's move to the next part. Prove that equal chord of a circle are equidistant from the center of the circle. So again, here what you will do, equal chord, they have given you the chords are equal and you have to prove that the length of the perpendicular will be equal. Okay, so first draw the part, you know, equal chords subtend equal angle at the center. Then you have to prove that they are equal. That means the perpendicular part has to be equal. Correct? So this is your radius. The perpendicular from center will bisect the chord. So this half and this half is already equal and that is 90 degree. So by CPCT both the triangles are congruent. So again you will say they are equidistant from each other. Okay, again I would just quickly show you on the diagram. Let's say you have 2 chords. They have told 2 chords are equal. So now let's say if the chords are equal, chalo, let us draw perpendicular on both the chords. You know, if I draw the perpendicular on both the chords, the perpendicular from the center bisects the chord. So let us say it is this chord, length of this chord was x. Let us say length of this chord was x. So now this part will be x by 2. And since both the chords are equal, if it is also x, this part will be x by 2. This is your radius, and 90 degrees. So right angle hypotenuse side rule, you can say both the triangles are congruent. So by CPCT, the perpendicular length is also equal. So easily questions can be solved. Okay, chalo, let's move to the next question. In the given figure, O is the center of the circle. Okay, and angle ABC, this angle is 45 degree. Okay, show that OA is perpendicular to OC. So here one important thing you have to remember, bachcho, they have given you that your angle ABC is 45 degree. So it's a direct theorem. Okay, about it, what is the theorem? That suppose if you have a circle, okay, and let's say that you have chosen an arc, AB. So this arc, suppose whatever angle it is making here at the center, okay, and now after this arc, take this arc out. Okay, if you take this arc out, so whatever point left on the circle, any point, suppose let's say here, if you join it here to here, or you join it here to here, or you join here to here, so all these angles, let us say, are equal to x. Why? Because you know angles in the same segment are equal. Okay, so if all these angles are equal to x, the angle at the center will be double of the angles at the circumference. This is what the theorem says. Now look clearly, bachcho, AC is your arc. Okay, AC is your arc. AC is your arc. So any other point on this point, any angle joining A and C from any point on this circumference, whatever angle. So this angle is 45 degree, correct? You can clearly see here. So if the angle this angle is 45 degree, you know that the angle subtended by an arc at the circumference is half of the angle at the center. So this angle at the center will be 45 into 2, which is equal to 90 degree. Correct? Direct proof. Direct proof it is. Okay, so this is how this question can be easily done. Okay, don't worry about it. These questions are bachon very easy, very easy. Okay, chalo, let's move to the next part. Done? Chalo. Proof of this part also, you can do it very easily. Okay, angle sum property you have to use, nothing else. So proof, how the proof will look. Suppose you have these two. Okay, and you have it here. So the chords, what they are saying. Okay, so any point here. So now what you will prove, let's say this point is here, na? So you have taken any one angle here. Okay, so now what you can say, that this is your radius, this is your radius, this is your this is your radius. Correct? So let's say if this is an isosceles triangle, so if let's say this is x, this will be 180 minus 2x. Similarly, let's say this is y angle, this is angle y, so this angle will be 180 minus 2y. So here this angle you have got as x plus y. And what will be this angle? This angle will be from 360 subtract 180 minus 2x. So plus 2x and minus 180 plus 2y. So you can see these will get cancelled. So this angle will become 2 times of x plus y. So double of that angle. So this is how easily, just angle sum property. This proof is the easiest one. Okay, so this is directly that application part. Chalo, let's move to the next question. In the given figure, O is the center of the circle. If angle BOC is 120 degree, then find the value of x. So here you have to understand this thing, bacho. First thing, two important theorems you should know. That first thing is angles in the same segment are equal, and angle at the center is double of the angle at the circumference for any arc. Okay, now see, they are given here angle at the center. Correct? So this is the chord, this is the arc BC. So any angle here drawn like this, I know will be of 60 degree. Correct? Will be of 60 degree. Chalo. So you might think, okay sir, let's make BC something like this, and we know this angle is 60 degree, but that will not help. That will not help me to get this angle x. This will not help me. Correct? So you have to think differently now, because that in this, other than this arc BC, any angle you are forming is not able to help you to get x. So what you will think now, in what direction you will think, whatever you can get it. O is the center, so OB is radius, OR is radius. If I join BC, can you get me these two angles? Sir, it is an isosceles triangle. So 180 minus 120, which is 60, 60 divided by 2 is 30. So these two angles will be of 30 degrees. Two angles will be of 30 degrees, right? Now see clearly. Whatever is needed now, I'm only keeping that part, rest all I am removing. Okay, chalo. And let me join AC. Can you see now that angle ADC and ABC are lying in the same segment because of chord AC? And you know angles in the same segment are equal, so I can say angle ADC is equal to angle ABC is equal to 30 degree. Okay, so sometimes you have to figure it out your way. First I started with angle at the center is double of the angle at the circumference, but that was not helping me out. Then I changed my approach. So this is what you have to keep your options open. Chalo, let's move to the next question. The next question is, in the given figure, angle DAB is equal to 60 degree, angle ABD is equal to 50 degree, then find angle ACB. Okay, so now again very easy bacho. This angle they have given is 60, this angle is 50, so I can clearly tell what will be the third angle in this triangle. So the third angle in this triangle will be 60 plus 50 is what? 110. And 180 minus 110 is 70 degree. So bacho, if it is, this angle is 70 degree, now AB is the chord and ACB and ADB both are angles in the same segment, so both should be equal to 70 degree. Understood? So the questions are very easy. Those who had a fear, whatever fear you had keeping for this chapter, that's a pseudo fear, bachon. The chapter is very easy, I'm telling you. Okay, so this is the end of this session today, and let me show you the homework question for you. The homework question is, in the given figure, AB and CD are two equal chords of a circle with center O. OP and OQ are perpendiculars on chord AB and CD respectively. If angle POQ is equal to 120 degree, then you have to find out what will be the value of angle APQ. The diagram is shown there. I want all of you to solve this question. Try to think the ways you can solve it. Okay, and let me know the answer in the comment box. Okay, I want this time more and more answers from all of you. Try to solve this question. Okay, bachcho. So this is all in today's class. I'll see you soon in the next class. Before that, Vedantu's app, bachcho, I have been telling you, do download the app because it's like all in one app. Okay, everything you are getting here: doubt solving facility, free study material, practice test, live class by the top teachers of master teachers of Vedantu here. So everything you are getting in a one app. So why not to download that part, right? Why not to download? Also, you can join the Telegram group. Many of the students are there having their doubts discussed and everything. Okay, so do join that group, Telegram group as well. And at the end, which is the most important thing, like this video, bachcho. Please like this video if you are really liking the videos. Before going, like this video so that others also get to know about this part. Share this video in your WhatsApp groups, in your class, to your classmates, everywhere, so that everyone gets to know about it. Yeah, you should help your friends, right? And subscribe to this channel. Along with that, press the bell icon so that you will get the notification of each and every class, and every day we are conducting classes. So all the classes you will get to know the schedule, you will get to know which classes are very important for you. You can make a timetable according to that. So it's very important. Do press the bell icon, subscribe to this channel, like and share to this video. Okay, bachcho. So this is all from my side in today's class. I will be coming back on Wednesday and with cyclic quadrilaterals topic, and I will do the proof of cyclic quadrilateral as well, because that's a very important proof which has been asked. Okay, bachcho. So this is all from my side in today's class. I will see you soon in the next class. Till then, bye bye, good night, see you soon, bye bye.